Hello guys, welcome to this lesson, and the topic in this lesson is Euclidean geometry, and Euclid is very interesting and it's a very important branch of mathematics. And I believe you're ready. You have pen and paper with you or a notepad, and here's the question here on the board. So let's start. Chord QN bisects angle MNP and intersects chord MP at S. The tangent at P meets MN produced at R such that QN is parallel to PR. Let angle P1 equal to X. So here's the diagram. What do we have to do? We must prove that MN over NR is equal to MS over SQ. So at this level of mathematics, this gives us a sense of what? Proportionality theorem. Yes. Good. So let's look at the keywords in the question. We have a chord, QN, okay? And this chord QN, what does it do? It bisects an angle, MNP. So MNP, meaning that angle N1 is equal to angle N2. And the same chord intersects what? Chord MP at S. Okay, so S is a point of intersection. And when two lines intersect, what type of angles are formed? Well, I hear vertically opposite angles. That's good. And then let's continue reading. The tangent at P, very important keyword, this one. It means somewhere, somehow, you need to apply what? Tan-chord theorem. If there were two tangents, that would be tangents from the same point theorem. Okay. So the tangent at P, so here's P, okay, meets MN produced at R such that QN is parallel to PR. So MN is produced to R. So the tangent meets the chord, which is what? Which is produced to point R. And the word produced means to extend. And in the process of extending, there's a formation of an exterior angle, okay? And clearly we can see that we have 4 points joined by line segments. Hence we have a what? Cyclic chord. Okay, so exterior equal to interior opposite angle. Yes, I believe we are, on the same page. Good. Such that QN is parallel to PR. That's a very important part of the question as well, because when you have parallel lines, proportionality theorem is present. When you have parallel lines, alternate angles, corresponding angles, and co-interior angles, or a combination, okay, if not at least one of those. So it's very important to know what parallel lines gives you indirectly, okay, in the question. And then angle P, we assign a variable to it. There we go, it's X. Okay, angle P1, I mean to say. Good stuff. So what can we do before we even come here? We need to, investigate what's going on here. So we have a tangent here, making contact with the circle at point P. There's a chord there called NP, and the tan-chord theorem says the angle between the tangent and the chord will be equal to the angle subtended by the same chord in the alternate segment of the circle. So this angle here. So it means this angle will be X. Let's go to the parallel lines. With the parallel line, there's a transversal here in the form of a chord. So what can you say about these two angles? Yes, alternate angles. So this is also what? X. Good. We see that there is a cyclic chord. That's quite obvious to see, okay? Meaning that angle M2 is equal to angle Q2. What is the reason? Angles in the same segment. Okay. However, in the beginning, we said QN bisects MNP, angle N1 equal to angle N2. So it was given like that. Hence, this will be X as well. Okay. Again, using the cyclic chord, angle N1 must be equal to what? Angle P3. Okay. angles in the same segment. What else can we say? Okay, base angles are equal. If we just focus on this triangle right here, QSP, it means that this is equal to that. This line segment QS is equal to SP because two angles in that triangle are equal. And what type of triangle is this one? Here in isosceles. Excellent stuff. Okay, so let me just close my laptop there. Okay, and then this triangle as well. What do we see? We see an isosceles triangle. Okay, so it means this is equal to that as well. Okay, we don't have enough information at the moment to say that indeed this line segment will be equal to that line segment, because we can still have the same triangles having, you know, two equal angles, yet the sides are not equal. Okay, so we just know that that is the case, and then yeah, I think we can leave it at that for now. So we can start in our solution of that question, right? Prove that mn over nr, okay, means there's proportionality where in this triangle mn over nr, okay, is equal to ms over sq. If we directly apply proportionality here, we can see that that is the proportionality because Sn is parallel to PR in the triangle MPR. So the intention then becomes that prove that SP is equal to SQ, and then that will be, you know, sufficient to prove this statement right here, and of which we have done that already through the equality of SP and SQ, because we have observed that the base angles are equal. Okay, good. So I think we can go for it. What do we know? We know that angle P1 is equal to X. This is given. Okay, and what do we know as well regarding the tangent and the chord? We'll subtend that angle there. So we know that angle M2 is equal to angle P1, which is X, and this is by tan chord theorem. Okay. However, what did we say? We have said that alternate angles here as well. Okay. We have angle N2 equal to angle P1. It's also equal to X, and this is by alternate angles because QN is parallel to PR. Okay, and therefore we have N1 also equal to X, and it was given in the question that those two angles are equal. Okay, so we have spoken about these three angles, and now we are ready to come this side because we need to change now the SP in our proportionality to SQ. Okay, so we know that angle Q2 is equal to angle M2. Why? Angles in the same segment. We're dealing with the cyclic quad now. Okay, angles in same segment. Again, N1 is equal to angle P3. Okay, so N1 is equal to angle P3, which is equal to X. Angles in same segment. Okay, and then we can now bring in our proportionality. Mn over Nr is equal to Ms over Sp. And this is through proportionality theorem because in this triangle Sn is parallel to PR. So the intention becomes to change SP to SQ, of which we have enough basis of doing that, because we now have what? Sides opposite equal angles. So it's a side, and they are opposite equal angles, and that is the reason. Okay. However, but what do we know? Angle Q2 is equal to angle P3. Okay, so P3 is X. We spoke about Q2, which is what? Equal to M2, which is also X there. Okay, so this was proven. We have shown it above. Okay, so these angles are equal. Now we can talk about this sides being equal. So therefore, SP is equal to SQ. These are sides opposite equal what? Angles. All right. And therefore, in our proportionality now, we can go back. In place of SP, we write SQ, of which is what we are required to prove. And therefore, we have MN over NR is equal to MS over SQ. And that will be a sufficient proof to this question. Okay, guys. Believe you were following. You're welcome to pause. You're welcome to, go back. And yeah, from the start, go through the process. Okay. What did we do? We made sense of the keywords, applied them to the diagram, see the connections, and then apply the connections. Now write it in a mathematical statement and reason setup. Okay, guys. So I believe you've enjoyed this lesson, and that will be me for now. Okay. So thank you very much and all the best. See you next time. Sharp, sharp.